Hello, and welcome to another digital design class. In the previous class, we started Boolean algebra and some postulates and theorems. Why do we use those postulates and theorems? We use them to be able to minimize a Boolean function and simplify it as much as possible. And the reason that we want to simplify it is that if we simplify a Boolean function, we reduce the number of gates. And by reducing the number of gates, we can make the system more efficient, faster, and simpler. And I give you some examples. Today, we were going to continue with the examples. I'll give you more examples, and I would solve some practice problems as well. So you would get more familiar with Boolean functions and how we can simplify them using the different postulates or different theorems. So we will continue with algebraic manipulation. We want to minimize Boolean expressions or functions. Again, we have the literal. The literal are it's a primed or unprimed variable, an input to a gate, like X, Y, Z, A, B, C, I already mentioned. And we have a term, an implementation with a gate, the minimization of the number of literals and the number of terms. When we do that, the circuit will have less equipment. It's going to be simpler and more efficient. Sometimes it's a very hard problem, and sometimes you don't get to a single answer. You may have multiple answers, and all of them are correct, and all of them would have the same number of literals and terms. And I'll give you some examples on that as well. Let's start with some examples. The first example, X and with X prime plus Y. If I want to simplify that, I can simply multiply X to the parentheses. So I would have X prime plus XY. We know that X and with X prime is equal to 0. If you multiply a term that we have is when we multiply a literal with its complement, we always have 0. And therefore, X plus X prime would be 0. And if we add anything to 0, for example, AB, we are left with that term, AB. Now for the second one, I want you to solve the second one. Again, you can use, let me copy this. This is very important. And put it here. Okay, so you can use these terms, and I want you to solve X plus X prime Y. X plus X prime. I want you to simplify this. You can use any of these postulates or theories to solve this and simplify it. So the first thing, let me give you a hint. The first thing to do is to look at the equation and tell me which equation or which theorem or postulate is this more familiar with. Is it familiar with postulate number 2, 5. Which one is this more familiar? Higher, I could say. Can I use this postulate over here? Postulate number 4, distributive law, 4b. Yes. So if I use 4b, what would the results be? So this is our y, for example. This is our z. X prime is our z. So x plus yz. So this would be equal to what? X plus y and with x plus z, which is x prime. Am I correct? Yes. Now, what is x plus x prime? Which postulate is x plus or x or with x prime? This one. Am I correct? What is x plus x prime? Is equal to 1. And what is x times 1? X. So x plus y and with 1 gives us x or with y. So the final result for the first one would be x or with y. Okay. Now I want you to go ahead and solve the second one. Second one is x plus y. Let me copy this here. So the second one is x plus y, x plus y, and with x plus y prime. I'll give you a few minutes to think on this. The first student to solve it gets extra points on their next homework. Again, you would look in this table and see which one of these postulates or theories are similar to our question. Again, there are multiple ways to solve this. Perfect. Yes, that's correct. The answer is yeah, x. So I'm going to solve it two different ways. First way, we can just simply multiply these two parentheses. So it's going to be x times x, and then y times x and y prime. Now, if I do that, we would have x and with x plus x and with y plus x y prime plus y prime. What is y prime equal to? 0. So this is going to be equal to 0. What is x equal to? This is equal to x. Yes. So I can write it like this as well. I can write x, and the rest I can write in a parenthesis. 1 plus y prime. Am I correct? Yes. Now, y plus y prime is equal to what? Y plus y prime is equal to 1. But the thing is, I don't even care about that. Even if I had 1 plus y plus z plus e plus d plus anything, the answer in this parenthesis would be still what? 1. Because adding 1 to anything results to 1. Because if I don't care if the rest is 0, if I just have 1 in the input, and this is like an OR gate with multiple inputs, and one of the inputs are 1, so I know the final answer would be what? 1. Therefore, x times 1 is equal to what? X. Or x and with 1 gives us x. So even if I had 1 plus x plus z, still this answer would be 1. It's like having, again, a 3-input OR gate, and one of the inputs are 1. The other ones I don't even know, and I don't even care, because I know the answer would be always what? 1. So this is one way to solve it. Another way to solve it is, again, we can use the distribution law. We have the duality. We know that x plus yz is equal to x plus y times x plus z. And it's true in the other way as well. So x plus y and with x plus z is equal to x plus yz. Okay. This is our x plus y. This is x plus z. Yes. So z is our y prime. So therefore, x plus y and with x plus y prime is equal to x plus y prime. What is y prime equal to? 0. This is equal to 0. So x plus 0 is going to give us, again, x. Again, we can solve it. I can solve it with 2, 3 different methods. Just looking at it, I can solve it with the theorem number 4 as well, but usually you're looking for the easiest way to solve it. Is it clear? Yes. Okay. Can I go to the next question? Yes. Okay. So problem number 3, I'm sorry, number 4, example number 4. X, y plus x prime z plus yz. So x, y plus x prime z, x, y plus x prime z plus yz. We want to simplify this. Again, I'll give you a few minutes. And the first student to solve this gets extra points and their homework. Again, there are multiple ways to solve this one. Did anyone? Was anyone able to solve it? XY plus
It's xy plus y.
very close. Very, very, very close. Okay. So we can write this again, multiple ways to solve this. One way to solve it, I can write it like this: xy plus x prime z plus the third term, I can write it like this: yz times x plus x prime, because I'm missing x in the third term. And we know that x plus x prime is equal to 1. Therefore, if I multiply it by yz, I have yz. So it doesn't make any change. So if I do that, this would be equal to xy plus x prime z plus xyz plus x prime yz. So xy is common between the first and the third one. And x prime z is common between the second and the third one. So I can write it like this. I'm going to write the rest down here. It's going to be xy 1 plus z, and with 1 plus z because I have one xy here and an xyz in the third term, plus x prime z, and with 1 plus y this time. So anything plus 1 would be equal to what? 1. So 1 plus z is equal to 1, and 1 plus y is also equal to 1. And anything multiplied by 1 gives us the same literal. So it's going to be xy plus x prime z. Again, what was your answer? Xy plus x prime y. So xy plus, and the second, the entire term was xy plus z. Okay. Okay, so plus z in parentheses, y plus x or x prime? X prime, yes? Yeah, okay. So what does this part look like? So this would be equal to zy plus zx prime. Am I correct? Yes. I want to see if I can, cy plus zx prime. Yeah, no, you're missing a term, but it's very close. Very close. You can simplify that as well, but it's gonna take a few more steps, but okay, so the final answer is xy plus x prime z. Now, how many gates do I have here? I have 1, 2, 3, 4, and a NOT gate here, 5. If I want to use 2 input ANDs, if I want to use, 3 input ANDs, I can combine these two. So 1, 2, 3, 4, 5. How many gates do I have here? 1, 2, 3. So I went from 5 gates to 3 gates, eliminating 2 gates. So it became much simpler. Now the last one, we want to solve x plus y and with x prime z and with y plus z. This is a practice problem. I'll just give you the final answer for this. So x plus y and with x prime plus z and with y plus z. And I'll give you a few minutes to think on this. And again, there are multiple ways that you can solve this. Let me bring back the table. So if you want to use the table, you can use. Let me write it down. X plus y and with x prime plus z and again with y plus plus. Does anyone have the answer for us? Do you want me to solve it? Yes? Okay. This part over here, doesn't it look like this? If I just switch, and I can switch z with x prime, and I can write it like this actually. Z plus x prime and with z plus y. So this is going to be like this part, and this is going to be like this part. And the answer would be, to these two, is going to be z plus x prime y. Am I correct? So using the distributive law, I can write it like this. The answer to this part is going to be z plus x prime y. Am I correct? Okay, so, and I can write this like x plus y times z plus x prime y. And now I can multiply them. This is going to be xz plus yz plus x prime yx plus x prime y y. Y and with y gives us what? Y. So this part is going to be x prime y. X and with x prime gives us what? 0. So this term would be 0. So we are left with xz plus yz plus x prime y. Can I simplify this further or not?
Yeah, the bottom left right there.
Mm-hmm. How can I simplify it?
Yeah, you can do the same method we did on 4. We multiplying x plus x prime into the yz term to get rid of it.
Exactly, we can do that. We can factor out a z, so z times x plus y plus x prime y. Yes. And then what we can do is we can add a z plus z prime over here, and we can simplify it further. So if I do that, it's going to be, again, we're going to go back to the second question that we solved. But let me tell you something. If we go through all of that, the final answer would be, I think I have the final answer, would be again x plus y times x plus x prime plus z times x prime plus z. And we can see that again, both of them have the same number of literals. So you're going to have multiple answers. All of them would be correct, but you're not going to reduce the number of literals and gates. So the other answer you may have is xy prime plus x z prime, which is the dual of this. Okay, so this is the final answer when we add z plus z prime and we simplify it. I don't have enough space to write the whole. Next question, we want to simplify the following. F is equal to AD prime plus AC prime D plus AB prime C plus ABCD. This was a question from last year's first exam. think it was in one of the exams, I think maybe first or second exam. And we want to simplify this. Does anyone have the answer? Yes, perfect. Yes. Okay, let me solve the problem. So A is common between all these terms. So I can write it like this: A D prime plus AC. So AN with parentheses D prime plus AC. Sorry, plus C prime D plus B prime C plus B C D. Am I correct? So again, between these two terms, C is common. So I can write it like this: C multiplied by B prime plus BD. But I'll write it like that. So this is going to be, am I missing something? Oh, I forgot this one as well. You can combine these three. And they're going to be C D prime plus B prime plus B D.
With the knot, that knot, C prime, and just move to a D.
So this is thank you. Yes. So if I want to factor out, let's do it again. I don't want to do everything at the same time. So it's going to be A D prime plus C prime D plus B prime C plus BCD. 1, 2, 3, 4. 1, 2, 3, 4. Let's do these two first. So this is going to be C times B prime plus BD. So it will be like this: A D prime C prime D plus C B plus B prime plus B D. Am I correct? Yes. Now, which one can I simplify further? What is B prime plus BD? If I go back to these postulates, which postulate is this? B prime plus B times Z. B prime plus B D. Which one does this look like? Can I write it like this one? Yes. So if I use absorption law, what would this look like? B prime plus BD. Am I correct? According to the absorption law, B prime plus BD is going to be equal to B prime. So this one, I can write it like this: B prime. So then we have A. Again, there are multiple ways to solve this. I'm just gonna try to use the easiest one. B prime. Now, how can I further move this one step further? What is the next step? Which postulate can I use again? D prime plus C prime D. What does this look like? D prime plus C prime D would look like what? D prime? Yes. What about D prime plus C B prime? I want you to think on it. That's the reason I'm
That absorption.
Mhm. I can't use it twice, absorption. When I have one parenthesis, I can't use it twice. I can use it when I have a parenthesis, but I can't use it, twice to do that.
Prime is BB. And say B that equals B prime. Would that B have to?
Yeah, let me give you a proof of how I came from this part to the lower part. Let's do it the way that we did it first. These two terms, what they are they missing? The second, this term, compared to the other terms, what is it missing? D and D prime, am I correct? So I can write this like this, B prime C times D plus D prime. Am I correct? Because D plus D prime is 1, anything and with 1 gives us the same term. So I can write this like this, A D prime plus C prime D plus C times B and with D plus D prime plus BD. And I'm going to close the parentheses. We're going to have 2 parentheses. Now here I would have BD plus BD prime. I'm going to prove the one that I just solved. Plus BD, and all of these are multiplied by C. And I have C prime D here and D prime here, and A. Now what is B? One of them should be B prime. Oh, I'm sorry, this is B prime. What is this BD with this B prime D? This would be B plus B prime times D. And B plus B prime is equal to what? 1. So 1 times D gives us D. So these two terms gives us D. Therefore, we're going to have A times D prime plus C prime D plus C times D, because we simplified that, plus B prime D prime. I'm going to go to the next page to continue solving it. So again, this is going to be A multiplied by D prime plus C prime D plus C times D plus B prime D prime. Again, here we have C prime D. Here we would have C prime D prime B, and here we would have C prime D. And when we combine them together, again, one of them is going to be equal to 1. So I would have A D prime plus C prime times D. Again, this would be 1 times D plus C B prime D prime. So 1 times D, this would be equal to D. Again, these two, I would have D prime plus D plus C B prime D prime. D prime plus D again gives us 1 and 1 plus C prime C B prime D prime. All of that multiplied by A. Now imagine if this is X, 1 plus X is equal to what? 1. So we don't care about this. This would be 1. And therefore 8 times 1 gives us A. There's an easier way to solve it. As I showed, you can use the distributive law and just directly jump from that x plus yz is equal to x, okay? So therefore, I could directly jump from this to the result. So in this case, it was, we can just straight go from, factor out c from these two. So it's going to be b prime plus bd. And b prime plus bd is equal to b prime. So therefore, I'm going to have cb prime, and then I have d plus d prime. I can multiply everything by c now, c plus c prime, and then I would be left with 1 plus a b prime c prime, a times 1 plus b prime c prime d, and 1 plus anything would be equal to 1. Therefore, a would be equal to 1. A times 1 would be. Okay. Let's do another. Do you want me to do another example, or do you want to go to circuits lab and start with the labs? What do you prefer? Do you want me to solve another one? Yes. Okay, let's do another one that I had from last year's exam. F is equal to A plus B times A plus C. We want to simplify this. This one is easy, actually. I'm sorry? Nope.
Is it A plus B?
Yes. Where was it? Okay. So first thing, we just multiply these two parentheses. So it's going to be A, B. It's going to be A plus AC plus BA or AB plus BC. So these two, we can write it like this: A multiplied by 1 plus C. 1 plus anything results in 1, and A times 1 gets A. So this would be equal to A plus A plus BA plus BC. Again, A plus BA is going to be A times 1 plus B, and 1 plus B is equal to 1, and A times 1 is equal to A. So it's going to be A plus BC. Equal to A, therefore we're going to have A plus BC. I want you to think on this at home. F is equal to A prime B plus BC prime plus BC plus A B prime C prime. And I'll post the next homework on Friday, and you have again 10 days to solve the second homework. Okay. That's it for today's lecture. Now let's start with the lab. For the lab, you can use the Circuit Lab. I would recommend that you all start your computer and search for Circuit Lab. So Circuit Lab is an online simulator tool. I think most of you are familiar with this. If you have had electronics with me, we did the lab simulation with this. But you can use any simulation tool that you want. There are a bunch of free ones. You don't need to go and buy anything. Circuit Lab is a good one, easy to use. You can go, and first thing you want to do is launch the Circuit Lab. And I'm gonna wait until you turn on the computers. There are a bunch of videos that you can see on YouTube, tutorials on how to work with Circuit Lab. It's pretty easy. Were you able to get in, all of you? Yes. You can use your own laptop for. Is everyone signed in? Yes. No. Did you send it? Okay. So it's. Mm. So you would start with launching Circuit Lab. You can start with a new project. And on the left, you would see the different components. You will have ground, different nodes, wiring, voltage source, current source, capacitors, resistors, inductors, which we don't use in this class. What we need in this class is down here, we have the digital logic gates, the buffer, NOT, and 3-input AND NAND gate, 3-input NAND gate, the NOR gate, the OR gate, 3-input NOR gate, 3-input OR gate, the XNOR gate, the 3-input XNOR gate, and so the counter and so on. So the first one, we just want to get used to it. I'm going to drag and drop a simple NOT gate. For this NOT gate, we need an input. I can put a voltage source as an input. You can connect it with the wires, but the easier way that I usually do it in these simulators, you just connect it together and you just, to make sure that they are connected, you can just drag it and you see that they are connected. You need to ground the other side of your voltage source. You can ground it like this. And for the output, you can give it, for example, to a source, which here could be an LED, a light emitting diode. You can also put a resistor, whatever you like. And then output, you can connect it to another ground, or you can simply connect these two grounds together. It's up to you. You don't need to if you put another ground for the output as well. Then you need to connect the input and output nodes. I can put one node for the input to measure the input voltage and the output voltage. By clicking on them, you can change the name. You can change this to V input. I can change the other one to V out. So V in and V out. I am clicking on the source. I can change the source voltage to Vs. And I can change the voltage to, let's say, 0 volts. So by clicking on it, you can change the name and you can also change the value. And also you can change the diode name, but I don't recommend, just leave it. And the NOT gate, also you can change the values. Now, if you go down on the left side, the bottom left, you can click on simulation and run the DC solver. And you can export the results. You can also see the DC sweep as well. You can run the DC sweep. And when you click on these, you can see all the outputs that you're going to have in the system. You can also run the time domain for these as well. But the only thing that you need is to run the DC solver. And then you can measure the output. So if you click on this, you can see the output is 3.26 volts and the input was 0 volts. So you have 0 volts in the input, you have 3.26 volts in the output. So you can see that this works as a NOT gate. And if I click on the input, just give me a minute, and I give it 5 volts in the input, and I want to run it again. Now, if I click on V out, you would see that the output would be now 0 volts. Yes, how can I help you? You got it? Okay. Now, is it clear? Did you all get the answer? Now, you can change this with any other type of, you can also do frequency domain as well. Obviously, we have a DC, so you don't have any, you don't have any frequency, so running the AC also doesn't make sense because we are running it in DC, but you can also do it in AC or any other, in frequency domain and time domain or any other domain that you like. Were you able to solve this one? Yes. Okay, so pretty simple and straightforward. Now, what I want you to do is I want you to go ahead and solve it for an AND gate. So simply add an AND gate here, connect it to one input, and then add another input here, and make this one, let's say, 0 volts. You can tie the grounds or have a different ground for this. You can add a resistor in the output, load, put it at 100 ohms, and add another ground, or you can just simply tie all of these grounds together if you want to use one ground, okay? Now we need another input. I'm going to call this V2. V2, and this one would be V1. So V1 is 5 volts, V2 is 0 volts. And now you can add the output node, and you can see that V output is 0 volts as well. I give it 1, 0, the result is 0. If I change this to, let's say, 5 volts, then I have 1, 1, and the output would be 1. Here is 4.5. If any of the outputs is 0 or less than 3 volts or 2 volts, let's change this to, let's say, 1 volt. Then the output would be 0 volts. Again, as you remember, we had the unacceptable, the threshold. So anything below, let's say, 2.5 volts is considered the logic of 0. Anything above 4 volts is a logic of 1. But to make it simpler, the logic of 0 here for you is 0 volts, and the logic of 1 is 5 volts. So 0, 1 gives us 0, 0, 0 also gives us 0. Now, what happens if I add a AND gate over here, a NOT gate? Instead of this, let's delete this and add a NOT gate. So if I add a NOT gate, if I have 0, 0 in the input, what would the output be? 1. So you can see the input is 0 volts. Both the inputs are 0 volts, but the output is 5 volts, which is the logic of 1. So in the Canvas, you can see the lab manual. I want you to go ahead and use the simulator tool to solve all the problems on the lab manual. And you can see it here. You can add the expressions here. And you can see if I give V1 0 volts, V2 0 volts, V out, which is from node 4, which is I can change the name to V out, would give us one. Let me add this expression over here. Now, if I run it, 0, 0 gives this one. Now, if I change this one to 5, now I have to register to continue. I don't want to do that, but you can do that at home. No, it doesn't allow me. So it has a limitation. If you want, you can pay for it, but for the first 20, I think you don't need to pay, or you just need to register, and it's going to be for free. There are other tools as well. Circuit Lab is one of the best, but you can use different tools that are out there. I've worked with a lot of them. This one is also not bad. For example, you can put an AND gate, and then you can put the logics 0 and another 0. For example, you can connect them together. It's exactly like what you had on the previous one. Circuit design gives, in my opinion, is one of the best. It's fast, it's easy to do, but you can use any type of simulators. This one is another simulator that you can use. It has different gates. You can put an AND gate, and then you can add the inputs, like an input of 1 or 0. You can add 2 inputs. And then you can connect them exactly like the one that you had before. And give it an output as well. Let's say it's a diode, and we want to see if it's turning on or off. And then you can run it. Also, you can change the inputs as well. I can change this from 0 to 1. You can run different circuits and so on. So this is another one, circuit simulator, that you can use. Another one is, just give me a second to see if I can. This is another one. Again, you have different logic gates. You can enter the different logic gates and enter the inputs, outputs, and so on. So for the output, we can have a lamp or an LED that simply turns on and off. And we can have inputs, 1s and 0s. Can add 2 1s. And let me see where the run button is. Yeah, it even generates truth table and so on. Nice. So this is another another one that you can use. So different methods different tools that you can use. The good thing about Circuit Lab is that it gives you the output voltages as well. So some of these tools don't give you output voltages, but Circuit Lab does that as well. I think it's enough. We're running out of time for today. Next week, we will continue with the Boolean algebra, and lab manual is already on Canvas. And there are some questions and truth tables at the end of each lab that you need to answer to those questions and fill out the truth tables. And also take a screenshot of the simulations that you do. Again, you can use any simulating tools. You can use PSPIs, anything that you want. And take a screenshot from the circuit and from its results, and just put it on a PowerPoint slide or a PDF and submit it as the lab reports. The lab reports you usually have 10 days. I'll put Dropboxes so you can put your lab reports and submit your lab reports as well. Thank you so much, and I will see you next week.